I write a weekly nature newsletter in which I explore a range of fascinating nature topics. And every week I end up with a lot of great material. So for years I've been thinking about making videos with some of this content because there's only so much that can fit into a single newsletter. So I want to use this content and talk about it a little bit more. And I thought I would start with the topic that first made me think about this. And that was about a year ago. I did a newsletter about autumn colors and aphids. It's not autumn right now. It might be autumn when you're watching this. But it's still a great topic because every year we celebrate and marvel at the arrival of fall colors. And it always feels like a bit of a miracle. But if you get curious about how trees produce these colors and do some research, you will find lots of articles that explain the mechanics of sugars and pigments. But it turns out that there's a much deeper story than people realize. So think about it this way. Rather than producing flamboyant colors, most leaves turn brown as they die. So what's going on with all these bright colors? Well, it turns out that trees increase their metabolic rates in the fall and use a lot of their energy to produce these red and orange pigments. In other words, this is an intentional rather than a passive change. And in 2001, some researchers proposed that trees might be producing these colors as a way of signaling to aphids. So all spring and summer long, leaves are green due to chlorophyll pigments that collect and convert sunlight energy into sugars that feed the plant. These pigments, together with the associated tissues that support photosynthesis, are built around scarce nutrients, and especially nutrients like nitrogen and magnesium. And a plant cannot afford to lose these nutrients when it drops its leaves in the fall. So a tree's goal is to break down and shuttle these nutrients to safe storage locations in its branches, its stems, and its roots before winter sets in. This is not only a very complicated process, but it's a delicate balancing act for plants. If you break down and store your photosynthetic machinery too early, then you miss out on critical days when you could be photosynthesizing. But if you wait too long, then an early freeze can kill your leaves before you have a chance to move the nutrients to storage. So what we see when we watch leaves closely is this gradual transition from green to yellow to orange or red. And what's happening is that as green pigments are broken down and moved from the leaf, they reveal underlying yellow pigments that have been hidden by the green all summer long. And at the same time, the tree is also manufacturing red pigments called anthocyanins. And again, this process takes energy. So producing these red pigments must be benefiting plants in some way. So you might be familiar with aphids from seeing these tiny sap-sucking insects on your garden or your houseplants. But there's a lot more to aphids than this. And let's start with the basic life cycle of aphids, which is in the spring, they hatch from eggs that have overwintered. At this point, every aphid is a female. And at the moment they're born, each female is already pregnant with her daughters, and her daughters are also already pregnant with their daughters inside of them. And then all spring and summer long, a female produces female babies that are exact replicas of herself, and those babies produce even more exact replicas. So if every baby survived and produced its own offspring, a single female could theoretically produce 6 billion copies of herself, all of them female, over the course of a single summer. And what this means is that aphids are phenomenally abundant and successful, and they play a critical ecological role, both for their impact on plants and as a food source for countless other animals. So producing a massive colony of exact replicas is a great strategy, but it doesn't help aphids when it comes time to reproduce and find new host plants. So aphids change their strategy at the end of the summer when females produce a new generation of male and female babies that develop wings. These winged babies then fly off in search of new homes. And the winged babies produce one more batch, the winged females produce one more batch of more female babies who are wingless, and they are ready to mate with the winged males. And then after mating, these sexual females lay eggs that survive the winter after all the adult aphids die off. And what's interesting about this strategy is that about 10% of the aphid species in the world use this winged phase of their life history to switch host plants. After spending the entire spring and summer on small herbaceous plants, these aphids fly off in search of trees where they secure their last meals and hide their eggs in the rough bark of the trees where their eggs are protected from predators and harsh winter conditions. So this search for new host trees is where colorful leaves seem to play a role. It turns out that as aphids fly around in search of new host trees, they intentionally seek out yellow leaves. Because yellow is a signal that a tree has begun breaking down its green chlorophyll and the peak amounts of nutrients have been unlocked and are being carried in plant sap from the leaves to roots. These nutrients are not going to be readily accessible when they're locked up in complex molecules, but when they're broken down into their component pieces and are flowing through the veins of a leaf, they are easily accessed by aphids. The most important nutrient for aphids is going to be the nitrogen they need to produce the greatest number of healthy eggs. What this means for trees is that having yellow leaves in the fall will attract lots of aphids, and then that tree is going to have a lot of aphid babies sticking around after they hatch in the spring. And this matters because aphids carry a wide range of plant viruses, plus they can drink so much sap that they can reduce the bulk of a tree by 2/3. So how can a tree solve this problem? Well, one hypothesis is that trees invest energy into producing red pigments that mask the yellow colors until most of the nutrients have been transported out of the leaf. In general, red colors signal that 70 to 80% of the nitrogen has already been moved out of a leaf, so it seems to show that most of the nutrients are gone and that aphids should just keep flying on in search of other trees. And in this scenario, it would benefit a tree to produce red colors earlier and hide the fact that its leaves are yellow and still actively moving nutrients. However, many trees still produce yellow leaves, so another strategy might be taking advantage of the fact that some species of aphids have unique relationships with ants. These so-called myrmephilous aphids provide honeydew to ants, and in exchange, the ants protect these aphids from other aphids and from insect pests that could harm the tree, which means that these trees might actually benefit from attracting the right kind of aphid. It's also telling that some trees, like alders, get a steady supply of nitrogen from bacteria in their roots, so they don't face the same need to conserve nitrogen like other trees, and they don't produce red leaves. So the idea that trees turn red as a way of signaling to aphids remains controversial to this day. There are over 80 published papers with over 10 different hypotheses and no final verdict. No matter what the story is, we know that trees have been co-evolving with aphids for nearly 300 million years. Their lives are complexly intertwined, and it's clear that trees are investing a significant amount of energy into producing copious red colors for some reason. What that reason is still a mystery to this day. Stay tuned to learn more.